On this video, I'm going to show you how to calculate the value of a European call option using the Black Scholes model. Now, before we go through a simple example, maybe there are some couple of things that it'll be good for you to understand the concept. Before we even go to this particular formula here, I'm sure you would remember the payoff of a call option is basically the S0 minus K. If you remember, the payoff of a call option is the difference between the strike, between the underlying and the strike, and the option is only valuable if the underlying is greater than the strike. So remember, S0 is the underlying, so I'm sure you remember that, and K is the strike. So the option is only valuable if the especially we are talking about a call option here, European call option. Call option is only valuable at expiry if the underlying is greater than the strike. So of course the formula might look a bit daunting sometimes if you're looking at it for the first time or not that used to it. So let's just try to understand some of the components of this formula. So basically this formula is the formula to value an European call option based on the Black Scholes model. So ND2, so let's start with this one. So ND2 is basically a probability. So here you can see what we are saying is this is the probability that the call option will be exercised in a risk neutral world. Now remember, every probability should be less than 1. The sum total of all the probabilities is 1, but a particular probability is less than 1. So we know that this value will be less than 1. So what we are saying is the call option might be exercised if the underlying goes above the strike, and the probability that the option will be exercised in a risk neutral world is this. So basically this is the probability that the option will be exercised in a risk neutral world. Now of course this n refers to a cumulative probability distribution function. So n of x is a cumulative probability distribution function for a variable with a standard normal distribution. Now basically what this means is that n refers to a cumulative probability distribution function. Remember, in a cumulative probability distribution function, it gives us the probability of particular value or any values less than that occurring. So it gives the cumulative probability. So the maximum value of a cumulative probability distribution function is 1, which means all the values less than the max value will take place. So that's ND2. So what we are saying is, okay, if we apply that probability into the strike price and then we discount that value to today, because remember, European call option will be only exercised at maturity, but we need to calculate the value as at today, so we need to discount it. We need to discount it for today. So that's what all this gives us. So this total value is basically the strike price discounted to today multiplied by the probability of that strike happening. So that's this component. Now here, so this whole value basically tells us that's the present value of the expected value of the stock in time t. Now this value, what it's telling us is, at maturity, of course, my stock price could go up or could go down, but its value today, if I calculate its expected value in the future and then discount it back to today, the price of my stock would be S0, that's the current stock price, times ND1. Now again, ND1 is a cumulative probability distribution function. So that's kind of the high level overview of trying to understand the formula. Now remember, it's always easy to start thinking about this as if you could think of it as if when you think about the payoff of a call option, you use S0 minus K. So basically that's my discounted present value of my S0, and that's my K discounted today with a probability applied to that. That's the high level explanation. Now there are two formulas for D1 and D2. Of course, if you understand D1, then you could apply to this formula here to calculate D2. So D1 basically it's the log of the underlying divided by the strike price plus the risk-free interest rate plus half of the variance. Remember, rho is the volatility of the stock, so rho square is the variance, and you divide that whole thing by the time to maturity and divide this whole component by the volatility times the square root of time. So that's your D1, and then that's your D2. So let's go through a simple question to see how we can calculate the value of a European call option using the Black Scholes model. So here we have been given the current stock price as $42. Now this question I took it from Hull's textbook. The current stock price is $42. Exercise price is $40. Risk-free interest rate is 10%. Volatility is 20%. So in order to calculate D1 and D2, so that's D1, we need to plug in these numbers. So S0 is 42 here. K is 40, which is a strike. Risk-free interest rate is 10%. Volatility is 20%, and time is 0.5, which is the time to maturity is 6 months. So if we replace these variables with these numbers, we would get D1 of 0.769263, and then we would get D2 of 0.627841. Now we need to calculate the probability related, the cumulative probability. Remember, we need to calculate ND1, which is the cumulative probability distribution, the cumulative probability related to 0.76923 and 0.62781. Now these are the values. So I have used a function called normsdist in Excel. Now in an exam setting, you could always use the tables that's been given in the exam. So you'll be given the cumulative distribution tables, and you can calculate the Z value using those tables. Of course, the values you might get using a table might not be as accurate as this, because the tables won't allow you to calculate the cumulative distribution up to this many decimals. So there might be a slight difference. So once you have ND1 and ND2, it's a matter of plugging those values into the call option formula here. So basically the call option price is, that's the S0 is your underlying, which is $42, and then ND1, which is 0.7791, minus your K is your strike price, which is $40, that's 40, and then the exponent of minus risk-free interest rate times to maturity, which is risk-free interest rate is 10%, 0.1 multiplied by time to maturity, which is 0.5, and then times ND2, which is 0.7349. So that gives you a call option price of 4.759422. So the exercise of applying the values into the formula it's quite easy. Once you know the formula, it's quite easy. But it's always good to understand why are you doing this, and what does the formula at least say at a high level. And remember, in an FRM exam, you you won't be getting these formulas, so it's better to write them and practice it a couple of times before the exam to be familiar with the formula.